The merge to sorted list problem is about working with references. The key here is that we will be given not a pair of lists, but a pair of linked lists. A linked list is a data structure which consists of multiple objects connected by references stored in the objects itself. Working with such lists requires some knowledge on reference types and how to deal with them. In some languages, those are more in the open, and in others, they are hidden behind the syntactic sugar. I will not go too deep into reference versus value types in this video. It will suffice for us to know that each object has its own place in the memory, and the reference is an address to this place. If we change an address of one object with an address of another object, we will change which object the variable references. The problem asks us to merge two sorted linked lists into one. Each object has a numeric value and a reference to another object, resulting in a chain of objects which we will call a linked list. In order to merge two linked lists, we will need to relink those nodes in the correct order. We will do that by changing the references. Both linked lists are sorted, so in order to merge them, we can just iterate through both of them and link the smaller element to the end of our new list. The iteration will be a bit more complicated than with a usual array, as the objects are not necessarily placed one after another in the memory and are not indexed. We will need to keep pointers to elements we will be working with. We will have one for our new list and one for each of our initial lists. It is important to understand that we are not creating copies of the objects or a new list. We are just relinking the original objects in one sequence. That might be a bit of a complicated concept to grasp initially, but it is an important one in order to understand how variables in programming work. We will create a new node which will be our starting point, and a reference to it which we will call current. Then we'll check iterators of both lists to check which one holds the smaller value. That node will become our next node, and we will move that iterator and the current iterator by one element forward. We will continue this until we reach the end of one of the lists. Then we will link the remaining part of the other list to our current iterator, and that should be it. Now let's go and implement the solution in Python and C++. First, we will define a new start node and create two references to it. We will use one to output our answer in the end, and another to keep track of the current position during our algorithm. Now we will launch a while loop which will be running until we reach the end of one of the lists. For each iteration, we will look at iterators of both lists and check which point to a node with a lower value. Then we will link our current node to that node and advance the iterator to the next node. We will also advance our current iterator to the next node. Once the loop is done, as we didn't touch any elements past that point, the tail of the list should be intact and just linking to it will be enough. Now we just need to output the first node of the list, which will be referenced by our starting node, which we created in the beginning. That should do the trick. The solution is linear in terms of time complexity, or O of n in big O notation, and it is constant in terms of memory complexity, O of 1, as we do not declare any data structures dependent on the size of the input. I hope the video was helpful and you found the explanation you were looking for. I wish you all the best in your learning. If you liked it, please like and subscribe for more content like this. If you have any questions, please leave them in the comments below. Thanks for watching and have a great day.